The universe, in its grand and silent march, seems to favor a particular state of being. This state is not one of intricate design or careful arrangement, but one of simple, unadorned disorder. Scientists have a name for this fundamental tendency. They call it entropy. Think of it as a measure of chaos, a cosmic accounting of messiness. When entropy is high, things are scattered, jumbled, and random, like a deck of cards thrown into the air. When entropy is low, things are structured, neat, and possess a specific, unlikely order, like a newly built house of those same cards. A tidy room, with every book on its shelf and every object in its place, is a small pocket of low entropy. A messy room, however, is a more natural state, a system that has succumbed to the gentle, persistent pull towards high entropy. Our cosmos began its existence in an exceptionally strange and precious condition. In the first moments after the Big Bang, the universe was in a state of remarkably low entropy, a point of unimaginable order and density. Since that initial, improbable tidiness, the story of space and time has been one of continual unfolding, of an irreversible journey towards greater and greater chaos. The stars burn out, galaxies drift apart, and energy spreads itself thin across the vast emptiness. This is the second law of thermodynamics at play on the grandest scale imaginable. The universe does not struggle against this tide. It moves with it, from a state of rare order towards a future of universal, featureless equilibrium. This relentless increase in disorder makes the existence of anything structured a profound mystery. The existence of stars, a planet, and the intricate dance of life itself requires conditions that are extraordinarily specific and improbable. These complex systems are like delicate, temporary patterns emerging against a backdrop of overwhelming randomness. They are islands of low entropy, fleeting anomalies in a vast ocean of chaos. To appreciate just how rare this is, consider the countless ways the fundamental particles of the universe could be arranged. The overwhelming majority of these configurations result in nothing but a uniform, uninteresting soup of gas and radiation. Only an infinitesimal fraction of arrangements could ever yield a star, a planet, or a living, thinking being. And yet, against all odds, here we are. We find ourselves living within one of these precious, ordered pockets. We are the inhabitants of a tiny island of complexity in a cosmic sea that trends only towards simplicity and disarray. Our existence feels solid and undeniable, but it stands in stark contrast to the fundamental nature of the universe we occupy. This apparent contradiction, this tension between the order we observe and the chaos the universe prefers, has led some of the greatest minds to question the very foundation of our reality. It forces us to ask how such an unlikely state of affairs came to be, and whether our perception of it is as reliable as we believe. It's a lot to take in. To keep order is a constant struggle against the current of the cosmos. A star is a delicate balanced gravity pulling inward and fusion pushing outward, a temporary structure that will one day exhaust its fuel and collapse. A planet is a collection of matter that coalesced in just the right way, a stable but ultimately transient body. And life, perhaps the most ordered phenomenon of all, is a breathtakingly complex chemical reaction, a pattern of information that must fight every moment against decay. These are the exceptions, not the rule. Like sandcastles built too close to the shore, magnificent for a time, destined to be washed away by the inevitable tide of entropy. The sheer improbability of our ordered world becomes staggering. Imagine a box filled with trillions upon trillions of atoms, all bouncing randomly. Most of the time you'd see a uniform, chaotic cloud. No patterns, no structures, no meaning. Now imagine shaking that box for an eternity. Very, very rarely the atoms might align to form a simple shape, like a perfect crystal. A minor fluctuation, a momentary dip in entropy, an even rarer event, a more complex object, like a rock or a drop of water. This idea captured Ludwig Boltzmann's imagination. He dedicated his life to entropy and the statistical nature of reality. He asked, if chaos is natural, how do we get long-lasting order? He used mathematics and probability to explore the riddle. In any vast chaotic system that lasts long enough, random fluctuations will occur. Most flickers are small, but given almost infinite time, colossal fluctuations become possible. This led Boltzmann to a startling, unsettling conclusion. He pushed the logic to its chilling extreme. If fluctuations can create order from chaos, what order is most likely? An entire universe, billions of galaxies, trillions of stars, a history stretching back 13.8 billion years? Or is a far smaller fluctuation statistically more likely? Perhaps a much smaller, efficient patch of order. A single conscious brain complete with a full set of false memories of a life it never lived. The idea is both simple and profound. It is called the Boltzmann Brain hypothesis. It posits that over the unimaginable timescales of an eternal or vastly large universe, the random collision of particles will eventually produce everything that is possible. However, the probability of a simple localized event is always higher than that of a complex, widespread one. It is easier to get one winning lottery ticket than to have every ticket in the world be a winner. By this logic, it is vastly more likely for a random fluctuation to assemble a single, functioning human brain than it is for that same fluctuation to assemble an entire solar system and Earth, the whole evolutionary history required to produce that brain naturally. This solitary brain, coalescing from the quantum foam or the thermal chaos of a distant future, would be a perfect, self-contained entity. For the brief instant of its existence, it would be fully conscious. It would possess a complete set of memories, a rich inner world that feels entirely authentic. It would believe it had a name, a family, a home. It might remember the taste of coffee this morning, the feeling of sunlight on its skin yesterday, the story of its childhood decades ago. It would perceive a universe around it, thinking thoughts, feeling emotions, and believing in a past and a future. But all of it, every memory, every sensation, every belief, would be a fiction, a complex pattern of neural connections that happen to form by chance. This is the unnerving core of the Boltzmann brain problem. If the laws of physics as we understand them, when applied to a potentially infinite cosmos, predict that the vast majority of conscious observers are these fleeting, disembodied brains with false memories, then we have a crisis of belief. How can you be so certain that you are not one of them? If you were to pick a conscious observer at random from the total set of all observers that could ever exist, the cold, hard mathematics of probability suggest you would be far more likely to select a Boltzmann brain than a human being who evolved on a planet over billions of years. Your entire existence might be nothing more than the most efficient possible way for consciousness to arise. This thought experiment is a direct challenge to our most fundamental assumption, that our experience of the world is real. It suggests that the feeling of having lived a long, continuous life might be an illusion. The entire history of humankind, the rise and fall of civilizations, the discoveries of science, the creation of art, all of it could be nothing more than an implanted narrative within a brain that just popped into existence a moment ago. This is not a dream from which you can awaken. For the Boltzmann brain, this fleeting, false reality is the only reality it will ever know before it dissolves back into the chaos from whence it came. So yeah, it's a pretty unsettling possibility. Let this idea settle upon you for a moment. Do not push it away. Address it directly. Consider your own memories, the very things that construct your sense of self. You remember your childhood, perhaps the specific pattern on the wallpaper in your bedroom, the feel of a favorite toy in your hands. You remember the faces of people you have loved, the sound of their laughter, the conversations you shared. You remember challenges you have overcome and moments of quiet joy. These memories feel solid, immutable, and deeply personal. They form the uninterrupted chain of events that leads directly to you reading these words in this very moment. They are the proof of your life. But what if they are not proof at all? Imagine that each of these memories, from the most profound to the most mundane, is simply a configuration of atoms, an arrangement of neurons and electrical signals in your brain. According to the Boltzmann brain hypothesis, This exact arrangement could have formed spontaneously out of a chaotic soup of particles just a fraction of a second ago. In that instant of formation, the entire narrative of your life was born, not through experience, but through sheer random chance. The brain that is you would flicker into being, fully formed, and its first and only thought would be a continuation of a life that never happened. It would feel completely, utterly sure of its own history. The horror of this idea is not loud or violent. It is a quiet, creeping dread. It undermines everything from the inside out. It suggests that the long, winding road of your personal history, with all its struggles and triumphs, could be a fabrication. That intricate tapestry of cause and effect, of learning and growing, could be replaced by a single, momentary spark of organization in an otherwise empty void. You, the person you believe yourself to be, might be that spark. Your existence could be a deeply convincing but ultimately hollow hallucination occurring in the silent blackness of an empty universe. A cosmic accident of unimaginable improbability, yet one that is still more probable than the alternative. This is not merely a philosophical game. It is a serious problem that physicists and cosmologists use to test their theories about the universe. If a scientific model of the cosmos predicts that Boltzmann brains should be vastly more common than real observers like us, that model is considered to be in trouble. It means the theory is probably wrong, because a theory that predicts its own observers are deluded is not a trustworthy theory. Scientists actively work to formulate theories of cosmology, of eternal inflation or the ultimate fate of the universe, that avoid this paradoxical conclusion. They reject models that fill the cosmos with these lonely, instantaneous minds because it feels like a path to madness. Even if the cold mathematics allow for these phantom minds to exist, their nature is one of ultimate brevity. A Boltzmann brain is a statistical fluke, a temporary rebellion against the overwhelming tide of entropy. It is an island of order that cannot last. The same random forces that brought the atoms together into a thinking pattern will just as quickly pull them apart. The intricate neural connections would dissolve, the stored memories would scatter, and the consciousness would be extinguished as quickly as it was lit. The pattern would simply fall apart, its constituent particles dispersing back into the featureless thermal noise of the void. For that one fleeting moment, the brain would have experienced what it believed to be a lifetime. It would have held within it the memory of watching a sunset, the feeling of falling in love, the knowledge of human history. It would have pondered its own existence, just as you are now. And then, without warning or ceremony, it would be gone. The brief fluctuation would end. The universe would not notice its passing. The silence that preceded it would be the same as the silence that follows. The quiet would be absolute, and the brief, complex thought would be erased as if it had never been at all. And so we are left here, in our seemingly stable world, small, cold, persistent question. You feel the weight of your own body, the air in your lungs, the solid ground beneath your feet. Your life feels long, continuous, and rooted in a real, verifiable past. But in the vast, indifferent theater of the cosmos, where time can stretch into infinity, the rules of probability can play strange and unsettling tricks. A random spark of pure information can be mistaken for a genuine history. A single, disembodied brain can contain the illusion of an entire universe. The thought is simple, sharp, and unavoidable.